Good evening, everyone. I'm Elsa Sharu Johnson from NIT Tiruchirappalli. So, here today we have week 3 of data science for engineers. So, people are still joining. I hope I am audible. Yes. Yeah. So, anyone have any problem in the audio? Yeah. Okay. Okay, fine. So, let's start with today's week 3 session assignment for data science for engineers. So, like last time, I'll be starting with assignments that had been given for July 2023 session, and then I'll be taking Jan 2023 session. Okay, so based on these questions, you'll be able to solve the assignments which are given in your present course. So there'll be some overlap between some of the questions because some questions will come both sessions. So in this week, you looked at random phenomenon. So the phenomenon or experiment where outcomes are not predictable with certainty are called random phenomenon. So sample space. So sample space is defined as a set of all possible outcomes of an experiment. It is given like, for example, if you are considering the case of a die, then rolling of a die, then it will be having these set of sample spaces given by 1, 2, 3, 4, 5, 6. So event will be any subset of such sample space. That means another example is like where the outcome is greater than 3. Okay, so for in that case the event will be given by 4, 5, 6. Okay, just I'll be going through the theory part quickly, then we'll move on to the assignment questions. Then probability, this also you have seen, it's a measure that assigns real value to every outcome of a random phenomenon, and also you can say it like a probability is the ratio of number of ways an event can happen to the number of ways sample space is present. So it's written like probability of E of an event is equal to n of E by number of the sample space, right? So the axioms of probability are given like it will be the value will be between 0 and 1 both included, meaning like the probability is non-negative and less than 1. Then it will be like the probability of sample space will be 1, meaning like the entire sample space will be having a probability of 1. And then P of A union B is given like P of A plus P of B, okay, for two mutually exclusive events. Okay, then so the question is like if all possible jumbles of the word, just wait a moment. Okay, sorry everyone. So if all out of all possible jumbles of the word bird, a random word is picked, what is the probability that this will start with B? Okay, so we are given a bird, word known as, okay, we are given this letter bird, and we have to find out the probability. For all cases it will start with B. Okay, so just this is just a simple example to show you the different types where you can have. So this is like the word is present, then we can fix one of the letters in that B, and then we can we can shuffle all the other three letters, other three characters. Okay, so this B is fixed, and with fixing that B we have 3 other spaces. So in that 3 other spaces, whatever can be filled, that will be the number of words which can start with the letter with the character B. So we have n of s as all possible jumbles of bird. So see here, there is no repetition for this bird, for this word. If repetition comes, then you have to account for that also. So right now all possible jumbles are 4 factorial. Okay, so 4 factorial is for the whole word which is known as bird, and then n of e, so that will be the sample space, and the event is like when it starts with the letter or the character B, so that will be the event. Okay, so then we have to find the probability. So probability will be like the denominator will be sample space and the numerator will be the event. So we can give it like denominator will be 4 factorial, numerator will be 3 factorial, answer will be 0.25. Okay, and in cases where there is a repetition, for example in the word banana, okay, the total number of possibilities you can have, in that case the sample space will be coming like 1 2 3 4 5 6 factorial will be there, and there are 3 occurrences of A and 2 occurrences of N, so it will be like in this way the total word can be arranged, so you have to account for that. But in our case right now we have only this one word without any repetition, so we can directly calculate this one. Okay, now then events are there are like 2 types. Mutually exclusive event, the occurrence, that means the occurrence of one event implies that the other event does not occur. Example is like a coin toss. If head occurs one time, then at the same time tail cannot occur. Okay, not both. Then another thing is like independent event, that means 2 events are independent if occurrence of one has no influence on the other. That means the landing of heads after tossing a coin and rolling a 5 on a single 6-sided die. These 2 are independent events. Then Venn diagrams you might have learned earlier. So these are the conditions, like if you see the whole region like this and inside the sample space, so this whole yellow region represents E union F, then this portion represents the intersection. Then if outside this particular event, it's known as E complement, and here F will be like a subset of E. Okay, then conditional probability, that also we have seen in this week. So if 2 events A and B are not independent, okay, that is one thing, they should not be independent for this condition, then the information available about the outcome of event A can influence the predictability of event B. That means P of B given A is given by P of A intersection B by P of A. So example is like 2 fair coins are tossed and the first event is like the first toss is head. Okay, that will denote HT and HH, and event B like 2 successive heads will be coming. Okay, so P of A will be given by, because the total sample space, total things that can happen is 4, right? This you might be aware, HH, HT, TH, TT. Okay, so total 4 cases are possible, and in that the event is represented by first toss is head, so that's why this number is 2. So it's given by N of A, which is 2, by N of S, which is the sample space, and then you will get 1 by 2, that is 0.5. Then event B is 2 successive head. Okay, so that means P of B is equal to N of B by N of S. That means only one case is possible, this one. Okay, so then you will get 0.25. Then even if the event A is given, then the probability of event B is, that means the event A has first occurred, then you will represent it by P of B given A. The meaning of it like P of E A, I mean the event A has occurred first, and after that we are calculating the probability of event B. So this calculation is done by this method, like first we will find out P of A intersection B divided by P of A. Okay, so P of A we had already found out, and P of A intersection B also will be like this only, because A contains this one, right, HT and HH, and event B is like HH only. So intersection of these two events will be like 1/4 itself. So that will be 0.25, and it's given by 0.5. Okay. Now random variable. So a random variable is a map from a sample space to a real line, such that there is a unique real number corresponding to every outcome of a sample space. So it's like kind of a map which maps it from the sample space to a real line. Okay. So in this particular, for example, the coin toss sample space HT can map to 0, 1. So there are two types in that itself: discrete random variable and continuous random variable. So discrete random variable, as you can understand from the name itself, a variable that can take one value from a discrete set of values. Example is dice rolling, given by 1, 2, 3, 4, 5, 6. And continuous random variable will be the variable that takes continuous range of values. Example, temperature of the week, given as a continuous set of values. Okay. Now, so next thing, probability mass or density function. So probability mass or density function will help us to assign the probability to every outcome of a sample space. So PMF, it's usually used for the discrete case, and density function is used for the random continuous random variable case. So in the discrete case, it is given like P of x equal to x is given by like, if for example in coin toss, it's taken like the sum of that event happening. So probability of x equal to x can be taken. We'll be seeing it with an example. For instance, like P of x equal to 0 means in coin toss that 0 we had represented for head, and 1 had been represented for tail. So P of x equal to 0 means it's 0.5, because probability of head will be half of the total sample space. So it's 0.5, and probability of x equal to 1 is 0.5. Then in the case of density function, it will be like you'll have an integral a to b f of x dx. Okay, that is like the integral of the distribution, continuous distribution. Now an example. So in this example, the box contains 20 defective items and 80 non-defective items. Okay, if two are selected at random without replacement, what will be the probability that both items are defective? That is the question. So we have 100 total objects, and in that we have how many non-defective and defective. We are taking 2 from this lot, and in that we have to find the probability where both the items selected are defective. So for that case, first we'll be starting with, so in these cases we'll need to use this formula NCR, which is given by n factorial by n minus r factorial into r factorial. Okay, so for that we'll have to see first what is the total sample space. So the total sample space will be denoted by 100 C2, right? Because from 100 total objects we are selecting 2, and in that we know that 80 are non-defective and 20 are defective. So we are selecting from a total of 100, 2 objects are selected, that's 100 C2, and then we know that from 80 non-defective items we are not selecting anything, and from 20 defective items we are selecting 2. Okay, so that's why I have written it like this. Probability of both items are defective means 20 C2 into 80 C0 by 100 C2. So if you solve this one, it will be coming like 20 into 19. Okay, and into this one will be coming like 80, and sorry, this will be coming like 1. Okay, and then the rest will be coming like 100 into 99. So the answer you will be getting is, so here there is one specific problem I haven't put 2 here, right? Because 20 C2 is 20 into 98, 19 into 18 factorial, I'll write, okay, by, that means 20 factorial by 20 minus 2 factorial into 2 factorial, that means here 18 factorial into 2 factorial, okay. So these will be cut and 2 also will be coming. So at the end it will be coming like 190 by 4950, okay. Here also there will be 2 will be coming, okay. So the total answer will be coming like 19 by 495. So that is the answer. Then distributions we will have binomial distribution, okay. So binomial distributions are usually like given in this form, okay, and it's calculated by n factorial by n minus x factorial into x factorial into p raised to x into q raised to n minus x, okay. We will see one problem in this one. Here n will be the number of trials, x will be the number of successes desired, p is the probability of getting a success, and q is the 1 minus p, that means probability of getting a failure. Then there is Gaussian distribution where the probability density is given, okay. So here it is like this is the mean value, and mu minus sigma and mu plus sigma will contain the 68.27% of the data. Then the 2 sigma, within the 2 sigma value, minus 2 sigma and plus 2 sigma, about 95.45% is coming, and 3 sigma will include 99.73%. So it's denoted by p of x is equal to 1 by sigma root 2 pi e raised to minus 1 by 2 x minus mu by sigma the whole square, okay. Then so yes, so then statistical sampling, that means population sample set, these two will be present there. So population will show the set of all possible outcome of a random experiment, will be denoted by population, and then sample set will denote the finite set of observation obtained from experiment. So it's like the population will be there, and from them some set of samples will be taken, okay. Then sampling will help to make inferences about the population. The inference may be uncertain because samples might be uncertain, okay, because it is some population, some samples which are taken from the whole population might not represent the whole population, okay. Then statistical analysis, there is descriptive and inferential. Descriptive means graphical, presenting the data in a plot, and numerical, summarizing the sample set, okay. Then inferential is like estimation, where you'll estimate the parameters of probability density function, and hypothesis testing, making judgment about f of x. So in this week you have learned up to the hypothesis testing part. So just I'll go through the graphical statistics. So there is like different types of plots, where there is a scatter plot. It will give you the plotting of values. So right now here you can say that the x-axis value is represented by daily temperature and number of visitors, like this. So there you can see, when you plot this graph, you can see the relation between the average daily temperature and the number of visitors in a particular day, when the temperature range was given like this. So here you can say, as the temperature is around the 96 degree Fahrenheit, there are a increase in number of visitors, okay. So this will like kind of shows a positive correlation you might have seen, or positive relationship is seen. Then histogram is present, where you'll represent in the term, in the type of continuous bar graph, okay. It's a continuous range is present, and you have kind of a bar plot. Then a box plot is present where you have different ranges, the maximum, minimum value and maximum value. Minimum and maximum value are given there, and this one denotes, like whiskers represents the outliers which are giving in the data. I mean, after this one the outliers will be present. Then the lower quartile Q1 represents the 25% of the data points. That means 25% of the data lies in this particular region. Then median represents the 50% of the data where it is lying, and upper quartile represents the 75% of the data points are lying in that region. Okay, so okay, so this is 75%. Okay, so that is like a box plot. Okay, so box plot will represent it like this. So whenever your data has more data towards the lower side, okay, then your box plot region will shift depending on the data. Like this, it might shift. It will start from a lower value, depends on the data. Okay, now numerical statistics, you have mean, median, mode, and also range. So mean is the average or norm. Okay, so if you have a number of observations given like this, 1 2 3 like this, and 7 observations are there, so the sum of the observation by total number will give you the mean. Then median will be the middle value. So here there are 7 observations, so 6 is the median value. If you have the number of observation as an even number, then what you will do, you will take the average of the numbers which are lying in the middle. Okay, so it's like if one more number was added here, maybe for example 9, and the total number now has become 8, then you will take the average of the 4th as well as the 5th number by 2, like that you will do and find the median, right? Then mode, most frequent value will be taking from this data, right? And difference between the lowest and highest value is known as the range. Then covariance and correlation. So covariance indicates the direction of the linear relationship between variables. The covariance values are not standardized. The value can be anything. So it shows whether the direction, okay, it's increasing or decreasing, like that, meaning like positive or negative. Correlation measures both the strength and direction of the linear relationship between two variables. Then these values are also standardized, meaning like the values will lie between -1 and +1. So the relationship, so how you calculate the covariance is given like this. Okay, xi minus the xi minus x bar, that is the mean, and yi minus y bar by n, sum of that by n. And if you have that, then that divided by sigma x into sigma y will give you the correlation. Then hypothesis testing. So it's used when we want to make decisions. For example, whether the effect of drug A is similar to drug B. Okay, so hypothesis testing is generally converted to a test of mean and variance parameter of a population. So it's like you have, for example, there are two-tailed and one-tailed test, right? So in two-tailed, it is like whether the mean value. So for this is in the case of a simple case where you will test whether the mean is equal to one particular value or the mean is not equal to one particular value. So it's like whether equal or not equal to, since that is coming, it's like a two-tailed, meaning like if it's not equal, mu can be either greater than this value or mu can be less than this value. That's why the distribution also, when we are taking, we will be defining a confidence level, okay, an interval we will be defining. So it's usually like you might have seen it like 95% confidence interval or 99% confidence interval, like that you have seen. So 95% confidence interval means in that particular interval you would not reject the H naught, which is the null hypothesis. Okay, the first thing written is known as the null hypothesis. For a two-tailed test, it will be usually like you will be saying the mean value will be equal to 23. Okay, then for an alternate hypothesis, you will be telling it's not equal. Okay, so if this particular value, okay, if the value that you are getting is greater than that particular confidence level, okay, in that level, then you will reject the null hypothesis. That means alternate hypothesis will be accepted. And that too, there are cases where the test will be one-tailed. So one-tailed is like the alternate hypothesis will be like greater than or equal to 23 if it's coming, then the alternate will be coming less than. So in that case, greater than 23 means this much. If it's greater than this particular interval, you do not reject H naught, otherwise reject H naught. Similarly for the right-tailed test also. Now null and alternate hypothesis. So this example that I have shown is like application of a biofertilizer X will increase the plant growth. That is alternate hypothesis. That means there will be a change. H naught will be like application of a biofertilizer X do not increase the plant growth. Okay, so null hypothesis is a hypothesis of which the researcher tries to disprove or nullify. An alternate hypothesis is a hypothesis which the researcher tries to prove. Usually we'll use these hypothesis testing in some cases where we will be trying to prove some certain values or certain dependence of some values on particular events or something. If we are trying to prove, we will be using this hypothesis. Then types of errors, this also you have seen in the lecture towards the end. So there are two types of errors, type 1 as well as type 2. So the truth in the case is whether if H naught is true and the decision taken or the prediction taken, if H naught is rejected for a true case, is not rejected, so that means H naught is true, then it's like the correct decision. Okay, so there will be one correct decision. So this is kind of like, if you are familiar with classification or anything, you might have seen confusion matrix. So this is similar to that. Okay, then if H naught is true and H naught is rejected, then it will lead to a type 1 error. Okay, and another case, if your truth is like alternate is true but decision taken is it's not rejected, that means the null, then it will lead to type 2 error. Okay, then H1 is true or alternate is true and H naught is rejected, it will be again a correct decision. Okay, so typically type 1 error probability A is also called as the level of significance of the test. It is controlled by choosing the criterion from the distribution of test statistics under the null hypothesis. Then you might have seen the trade-off between these two errors. For example, if you have null hypothesis drawn in this way, the distribution drawn in this way, and the alternate hypothesis drawn in this way. Okay, sorry. Then okay, wait. Yeah, so if you have like that, then this particular value, if you are giving as a threshold, okay, the threshold is defined in this particular value, then what will happen is that, okay, just I'll take a different color. Yeah, so this much portion will be like the case where the alpha will be coming. Okay, then if you are like stretching this one, the place where this much portion will be rejected will be increasing and here this will be decreasing. So you might have seen this graph in your lecture also. I think I can like show it clearly. Okay, wait a moment. So here you have two graphs, okay. Both one represents the H0 and other represents the H1. This is H0 and this is H1, and then you are defining a level of significance as alpha. So this particular region, will be like the type 1 error because it's denoting H0, and the other one represented by this one, the black region, will be representing the type 2 error represented by beta. So if you are shifting, so this particular this particular line, okay, if you are shifting it to the right, okay, then what will happen is that this particular line will reduce the type 1 error, but what will happen to the type 2 error? It will increase. So that is a trade-off, okay. Now, so we will move on to the next one. Then this is a question, okay, so we will be starting with the question. So till now what you have seen, it is like you have seen the basic theory which was taken last time. So now we'll move on to the question. So here, so I'll just start this, okay. Yeah, so it's given, suppose x belongs to normal distribution of mu and 4. So here it's like, so it's like n is given as 20, n equal to 20. Just wait a moment. Okay. So it's given n equal to 20 and samples of x, observed sample mean is 5.2. That is also given. So I'll give it by x bar equal to 5.2. Meanwhile, you can also calculate and give the answers, okay. So x bar is 5.2 and sigma square, which is the variance, is given by 4, okay. Then we are asked to do like what conclusion would an Z test reach if the null hypothesis assumes mu equal to 5. So the null hypothesis is given by mu equal to 5 and the alternate hypothesis will be mu is not equal to 5, okay. Then you are given with the significance level of alpha equal to 0.05, okay. So what should you be doing? Then it's like you have this mu value, sample value, hypothesis also you have the number of observations, then you have to find the Z score. What is the Z score? So it is given by 5.2, which is, so it will be given by x bar minus mu by sigma by root n. That is the way in which you should calculate. So it is given by x bar is equal to 5.2 minus mu is given by 5 and sigma is 2 by root 20. So you will be getting, anyone have got the answer for this one? So it will be 0.2 by 2 by, I think I can write it like 2 by 2 root 5. So the answer, have you got the answer? So the answer will be 0.4545, okay. So when we look at the thing, right, so when we look at what is the confidence interval or a significant level, we are asked to calculate for a significance level of alpha equal to 0.05. So alpha equal to 0.05 means the acceptance range will be like 95%, okay. So set score for a 95% is defined by this value. It's like given, if it's two-tailed, it's given like plus or minus 1.96. That means whenever the set score that you calculate and obtain is greater than 1.96 or it's greater than minus 1.96, you have to reject the null hypothesis. But in this case, it's 0.4545. That is like between this value. It is between minus 1.96 and plus 1.96. Okay, this coming between this value, right? So what is happening is like you can accept the null hypothesis. Okay, so that's why the answer will come like accept H0. Okay, so that will be the answer for that one. Then I think this is clear to everyone, otherwise I'll explain it once more. Okay, so we'll move on to the next one. So next one is similar. Okay, I think this came in your last assignment. Okay, explain once more. Okay, so just I will clear everything. Yeah, so the thing is like VR defines like one event, like it is like a normal distribution with mean mu and variance 4. Okay, so we have a population mean like mu, okay, and variance is given by 4. Okay, that means these are all quantities of a population taken from a whole population. Okay, now then we are taking some samples from the population. So some samples means the samples will be having the sample mean as well as sample standard deviation. Okay, sample standard deviation is given by S. Okay, so right now we have a population mean. That means it's like, for example, if you are seeing how many people in your particular population have a particular prevalence for a disease or risk of getting a particular disease, then without finding the risk for the whole population, like without finding the risk for the whole population of India, you will be taking from some samples from each part of the state, each different states of India, like that some samples will be taken, and then you will be analyzing that sample and giving your hypothesis. So likewise, the same thing, there is a population and that population mean and variance are given, and we are taking some samples, the sample number from that population. We are not given what is the number of the population, we are just given how many samples were taken. Okay, samples we are given, and the observed sample mean, we have observed that the sample mean has come like 5.2, and we don't know what is the sample standard deviation, that we don't know. Okay, then we are asked to find out what conclusion would a set test reach. Okay, so set test is kind of used in these cases where we have to see whether the population mean is equal to a particular number or not. That is where set tests are used. There are different hypothesis testing methods, and set test is used in a case where the null hypothesis is given by your particular mean is equal to a particular value, and then alternate hypothesis will give that your population mean will not be equal to a particular value. Okay, that is what a set test gives you. Okay, so in that set test itself, you will be telling your hypothesis with certain level of confidence. Okay, that is known as this much percentage confidence level. So here that is represented by alpha, and we are asked to do as it for a confidence of 0.05, or it is like significance of 0.5, that is the term mentioned. So for significance of 0.05 means it's like 5% significance. Okay, that means your whole interval, confidence interval, if it's like a norm, so this is like a normal distribution, right? So in this normal distribution, it will be coming like this much percentage. Okay, so if it's like two-tailed, this is like we are not, this is two-tailed, right? Because we are just saying whether the population means is equal to some value or not equal to some value. This so this is two-tailed. Okay, so if it was like population mean was less than or equal to some value and population alternate hypothesis is greater than some value, it is like one-tailed test. So this is in our question right now, we have a two-tailed test, so that is okay. Then what we need to find out is like this one. So this one is like 5% significance level. That means that the other percentage, that means this much portion is the place where the null hypothesis is accepted. So in this blue area, we will be accepting H naught. Okay, so that means like 95% of the data is there accepting H naught. And in the other case, so it's like 5% significance, right? So 2.5 will be going here and 2.5 will be going the other side. So this particular place, it is like if the value from, if the set score value that you are getting is beyond this particular value, one particular value will be there. Okay, one particular interval value will be given, and if it's beyond this value, then you will have to reject your null hypothesis. Okay, so if it comes in this area or this area, it will be like rejection. Now we have to find the value where this particular test falls. So for 5% interval, it's like usually it is like you can check the charts and all, and it will be given like here it will be 1.96 and here it will be minus, sorry, here it will be minus 1.96. okay, here in this case it will be minus 1.96. so just we have to check what is the set score value that we are getting. So here right now our hypothesis is like mu is equal to 5, population mean is 5, that is our null hypothesis. And what we are trying to prove is that the population mean is not equal to 5, the population mean is not 5. Okay, so that will be the alternate hypothesis. Okay, so H naught denotes the null hypothesis and H1 denotes the alternate hypothesis. Okay, I think that's clear till there. So now we have to calculate the set score value. So set score value is usually calculated, no, it's calculated with the formula x minus mu by sigma. Just wait a moment. Yeah, it's calculated by z equal to x minus mu by sigma, you have learned. Okay, here in this case you don't know the sample standard deviation. So what you will be doing, so this here set score value will be calculated by x minus mu by, here sigma by root n will be the set score value. Okay, then you know the x value. X value is kind of like, okay, I'll put x bar, so it's like x bar here, right? So x bar is given like 5.2 minus, I think is visible, or otherwise I'll change the ink. So it's like, so it's written like 5.2 minus mu is given by 5 because we are trying to prove whether mu equal to 5 or not, and then the sigma is given by sigma equal to 2. Okay, because variance is like sigma square is 4, right? This is like sigma square, so sigma here 2 by root 20. Now so you'll be getting the answer like what I said, 0.4545. okay, so you got this set score value here. Now if you look here, the set score value, so this is the 0 point. Okay, the set score value that you got lies in this region, right? This region means it comes in the blue region. So it is less than the 1.96 value. So what you will have to do, you have to accept your null hypothesis, which states that H naught, or your population mean, is equal to 5. Because you don't know the population median, you are just assuming that. Okay, so then it means that can be accepted, that particular hypothesis can be accepted. So that's why the answer here will be coming like accept H naught. So is it clear now? Okay, so we'll move on to the next question. Here also it's similar to the earlier question, but still we have to find out with what significance level we have to prove that. Okay, so in here the question is given like x is, this also you can parallelly calculate. Okay, so it's given like x belongs to normal distribution with mu and sigma square equal to 9, then n equal to, so it's like normal distribution of mu comma 9, and the number is given like 100. Then observed sample mean, that means x bar is given like 11.8. So what conclusion would a set test reach if the null hypothesis assumes mu equal to 10.5? okay, against a alternate hypothesis which is understood like mu not equal to 10.5. So here also they are asking for, they haven't asked for a significance level. Okay, so then you have to see the options and do that. That is only difference in this question. So as always, you'll find the set score value for this one, that is x bar minus mu by sigma by root n you'll be doing. So that means it is like x bar 11.8 minus mu 10.5 by sigma. Sigma is coming like 3 by root 100, which is 3 by 10 it will be coming. Okay, so the answer I think will be coming like 4.33. okay, just you can check that. Okay, then so here you can see there is two significance levels given. Okay, there are two significance levels given. So here there is a significance level of 0.10 and 0.05. So first we'll assume that the significance level alpha equal to 0.05. So in that particular level, what was the set score standard deviation? It is like you can see here, sorry, not that one. Okay, just wait a moment. Yeah, so less than 0.05 p value and confidence level 95% is should be like less than minus 1.96, or it is like greater than 1.96. that is the level. So in this particular case, this is like 95% level, right? So in that particular level, that means significance level of 0.05. if you see the value, okay, the value is coming like 4.33. so what will happen if you see 95%, which is like plus 1.96? anyway it is higher than 1.96, so it's reject, right? Yeah, every one person has answered reject H naught with a significant level of 0.05. now again it's very easy, you can just see 1.10. so if you do that, that should also be like, if it's greater than 1.65 it should reject. okay, so here it's greater than 1.65, there also reject. so answer will be like reject H naught at a significance level of 1.0 and reject H naught at a significant level of 0.05. okay, both are the answers. Now next question, The correlation coefficient of two random variables are given like x and y equal to minus 1.4. Their variance is given by 3 and 5. Compute the covariance of x and y. Okay, so in this particular case you are given with the correlation coefficient. Okay, the relations you had seen, correlation coefficient r of xy equal to covariance of xy by sigma x into sigma y. Okay, so in that case what you should be doing is like, you have this value minus 1 by 4. I think in some of the questions it was written like minus 14, but the answers were this only, so actually it's a mistake in the question. Okay, its original value should be like minus 1.4. if you are having this question in your present assignment, just check which is the answer, I mean question given. Okay, so it has come mistakenly in one of the questions, but same answers were given. So anyway, like minus 1 by 4 equal to covariance, we don't know, that's what we have to find, covariance of xy by sigma x you have, okay, will be root 3 and sigma y will be root 5. Okay, so this you will be calculating directly and you will be getting the answer. That's straightforward. Okay, so I'll move on to the next question. A car manufacturer purchased car batteries from two different suppliers. So supplier X, so just I will, okay, so two different suppliers are there, X and Y. Okay, supplier X gives 55% of the batteries, that means automatically 45% will be in supplier Y. Then 5% of all batteries from suppliers X are defective. So this is like the total one which are bought from there, and the defective is given by 5% of 55% is defective. Okay, and 4% of batteries of all batteries from supplier Y are defective. So these are the data which is given. Okay, then you select a battery from the bulk and you found it to be defective. So your probability, what you will be have to find is that you select a battery from the bulk and you found it to be defective. Okay, so what is the probability that it is from supplier X? So first you found a defective battery, then you have to find the probability that, so you have a defective battery, you have to find out the probability that it is from supplier X. Okay, so a similar thing you have found out earlier. So how do you find this out? First you have to find the probability of selecting defectives. Okay, so probability of selecting defective batteries is given by, just give like defective, okay, is given by probability that battery from X, okay, is defective, and or it can be like probability of battery from supplier Y is defective. Both cases can happen. So here, so right now we know that 55%, that means like 55% is from X only, right? So 0.55 into 5% of that means 0.05. Okay, or means like plus you have to add, it's like 0.45 into 4%, 0.04. Okay, so total if you calculate, it will be coming like, so this will be coming like, is it 0.604? Everyone, can you just check the answer? I am getting the answer as 0.0455 here. Okay, and okay, just check that once more. Then what we have to find? We have to find the probability that the defective is from supplier X. So we have seen that earlier. It's like probability that X intersection defective by probability of defective. So probability of defective we have already found out, and probability of this one is like 0.05 into 0.55 again. Okay, just going through the steps, it's like how you have to find that out. Okay, so it's like 0.05 into 0.55 divided by the answer will give you, yeah, this one is 0.604. So I think you have given the final, yeah, that's fine. Okay, so 0.604 is the final answer. I hope this is clear. Any questions you can ask, okay? Otherwise I'll move on to the next one. Okay, so I'll move on to the next one. Then the next thing is Sumit wants to contact one of his friends, but he remembers only the first 9 of the 10 digits of the contact number. He's sure that the last digit of the contact number is an odd number. Okay, then he selects an odd number randomly. Okay, so he knows 10 of the digits, 1 2 3 4 5 6 7 8 9 10. Okay, so this particular digit he doesn't know. He selects an odd number randomly. So total, anyway, the cases which are possible are 10. Out of that, odd number, he's sure that the last contact number is an odd number, so 5 odd numbers are there. That means the random variable will be given like 1 3 5 7 9. Okay, these are the things that is possible. So now you have to find if the random variable X denotes the last digit. So this is represented by X. Then calculate variance of X. So what you have to find first, you have to find the mean. So mean is like these whole numbers can be added and it will be divided by 5. The answer will be like, it will be coming around 20, right? Or what you are getting? Okay, the mean is coming like 5. Yeah, that is true, right? Now you have to find X minus mu. Then you have to find X minus mu the whole square, and then expectation of X minus mu the whole square will be your variance of X. Okay, or it will be like you have to find 1 by n sigma summation of X minus mu the whole square. If you find that out, you will get the variance. So first what you will have to find, X minus mu, then mu is 5, no, so it will be coming like minus 4 minus 2 0 2 4, and the whole square will be coming like 16 4 0 4 16. Then you have to add these up. Okay, 32 plus 8, it will be coming like the total X minus mu the whole square summation will be coming like 40. Then divided by the number, total number is 5, that means 40 by 5, it will be coming like 8. Okay, so the answer is 8. So this is the variance of X. Now we have got an example question. So it's like a big number, big set is there, so it will take some time to calculate in here. So anyway, suppose the IQ in a certain population is normally distributed with mean mu equal to 100. Okay, so mean is given like mu equal to 100 and the standard deviation is given like sigma equal to 15. So this is like population mean and standard division. Okay, standard deviation. A scientist wants to know if a new medication affects the IQ levels, so she recruits 20 patients. So mean of mu 100, yeah, recruits 20 patients to use it for 1 month and records their IQ levels at the end of the month. Okay, then these are the 20 samples which are given. Okay, write a code to show how to perform a one sample set test in R to determine if the new medication causes a significant difference in IQ levels. So if you do this problem, anyway, you have mu, you have sigma, and you have n equal to 20, then what you need to get is like you need to get the sample mean. So sample mean, you can just add these up and calculate that. You will be getting, so addition of all these values, you don't have to do it now, but I think you'll be getting like 103.5. okay, it's like the total addition of these values divided by the number, total number. Then our hypothesis is like H0 gives like medication will cause a significant, if we want to determine whether the medication causes a significant difference in IQ levels. So null hypothesis will be like mu equal to 100. Okay, so there is no significant difference in the IQ, and alternate hypothesis will be like there will be a significant difference in IQ. So for this we will move on to the R Studio right now. Okay, so in that I have entered this data. Okay, so for that it's better you have installed the library known as BSDA. Just I'll clear the variables, everything. So I hope the window is visible, right? Yeah. So here the IQ levels are given. So for 20 patients is 88, 92, 94 up to 115. This is the data. So we'll load this data first. Okay, so it's available here. Now we want to perform Z test. Okay, so for that I need the library. So I am installing the library BSDA. Then how do you do? It's very simple. You have to give set.test. okay, data will contain where you have to perform the set test or the samples which you have to give. Then mu will denote your mu, which is 100, and sigma dot x will tell the deviation. Okay, standard deviation. So if you give like that and just run, if you run this code, you will get the set score. It's very simple. So it's like one sample C test it's given. Okay, so set score is coming like 0.909. okay, so that's the set score value, and p value is coming like 0.3632. okay, so usually when you will do for, so right now we had given like mu equal to 100, and that is the null hypothesis, and alternate hypothesis was like mu is not equal to 100, meaning like the IQ is not varied, no variation in IQ, and the alternate hypothesis had told that there is a variation in IQ. okay, so that's what we are trying to prove. okay, so we are going to determine if the new medication causes a significant difference in IQ. So we are trying to prove the alternate hypothesis. I already told you last time, now whatever we are trying to prove will be in the alternate hypothesis. So that's what we are trying to do. Now here we have seen that p value, or it will be giving you the how much significant your finding is. okay, so it has calculated for 5%, 95% confidence interval. Just wait a moment. So here you can see that it's given for 95%. Okay, and then sample mean, the mean of x also is given. That's what I have given there. Okay, now you have got the p-value as 0.3. so in the case when you are seeing a normal sample C test, okay, if your value, p-value that you are getting is greater than 0.05, then it means that your alternate hypothesis should be accepted, or you should reject the null hypothesis. That's the meaning. So from this test, if you are getting like p-value is greater than 0.05, that means that finding is significant and you have to reject the null hypothesis. So from this, what you will know that the alternate hypothesis is true. So that means there is a variation in IQ. So the answer for that will be, in this particular case, it will be like, yeah, it will be like new medication. So we will be accepting the new value. Okay, so this one H1 will be accepted. That means that new medication has a significant difference. Okay, that is the answer. Okay, now there is another variation which you can observe, that also I've given a second example. So this is like you have, so right now we had a set of sample for 20 patients from a population, and now we are seeing whether the introduction of a medicine has a change in the IQ levels. Now for another example, if you have a 2 sample C test, example for a 2 sample C test, that means like IQ levels of 20 individuals from 2 different cities are available in a particular population. So for city A there are 20 samples, and for city B there are again 20 samples. So such a kind of, if such a kind of example is given, then it will mean like a 2 sample C test. Okay, so I have run these 2 values and loaded that, okay, to the environment. Then the same thing, we have to give C dot test x equal to city A and y equal to city B. Earlier we had just given like data. Okay, now we have to inform it like that, x equal to city A and y equal to city B, mu equal to 0, because we are trying to find out difference in IQ levels in the 2 cities. This time it's like that, whether we have to see whether the 2 cities are having same IQ levels or different IQ levels. So that's why mu I have given as 0. Deviation is mentioned as 15, and for first city, and for the second city it's like y equal to 15. Okay, so I'll just run this value also, and we will see how it comes like. So here they'll find the mean of x as they have found it like 100.65, and mean of y as 108.80. Now you can see the z value have come like this, and the p value is like this. Okay, so the p value is like, now it's like again it's greater than 0.05. That means the null hypothesis is rejected and the alternate hypothesis is accepted. That means that the two true difference in means is not equal to 0, or it means that the IQ levels of 2 cities are different. Okay, so if you want to have any more information about this C test, I have given you a link, and I'll be sharing this R file also. You can go through the different variations in which you can do this particular thing. Okay, now next one, we'll move on to another question. A box contains 8 items, out of which 2 are defective. A sample of 5 items is to be selected randomly without replacement from the box. If the random variable x represents the number of defective items in a selection of 5 items, then find E of x. Okay, up to 2 decimal places. So what you can see here is like total there are 8 items. Okay, totally there are 8 items, and in that 2 are defective given. Okay, so defective is given as 2. Then if random variable x represents the number of defective items in a selection of 5. Okay, so random number x, there are anyway 2 defective items only, so the selection is like for 5 items. So anyway the random number random variable will represent whether there are 0 defective items, or whether there are 1 defective item, or whether there are 2 defective items. So this is the case that the x can take. And then so defective is 2 means non-defective will be 6, right? So I think you can also solve this one and tell the answer. Okay, so anyway first what I'll be doing is like I'll be doing for p of x equal to 0. So that will mean like 6. So x equal to 0 means 0 defective items, right? So that means the 5 non-defective items or 5 items are taken from the non-defective set, and from the defective set nothing is taken, and then it is like there are total 8 items, and from that 5 items are selected. Okay, so that means here it will be like 6 factorial by 6 minus 5 factorial into 5 factorial, right? So it will be 6, right? And just I'll write that 6 factorial into by 6 minus 5 factorial into 5 factorial will be coming like this. Okay, now so it can be cancelled, and into 2c0 means 2 factorial by 2 minus 0 factorial, that means 2 factorial into 0 factorial, that will come as 1. So this also cancelled. By 8c5, that means 8 into 7 into 6 into 5 factorial you can give, and at the bottom it will be like 8 minus 5 factorial means 3 factorial into 5 factorial. Okay, so these will be the answers. So it will be coming like 6 by 1, and here it will be 8 into 7 into 6 by 3 factorial will be 3 into 2, that will be 6. Okay, so at the end it will be coming like 8 into 7 itself, right? So 6 by 56 will be coming. Okay, then that will be p of, I'll just write it as 6 by 56. So p of x equal to 0 came as 6 by 56. Now we have to find p of x equal to 1. Okay, p of x equal to 1, then that will be coming like 6c4 into 2c1 by 8c5. Okay, so this answer will be coming, that will be like 1 defective. Okay, so 2c1 6c4, so it will be coming like around 30 by 56, right? It will be like 6 into 5 by 6 minus 4, yeah, into 4 factorial, so like this, and into 2c1 it will be like 2 factorial by 2 minus 1 factorial into 1 factorial, that into 2 it will be coming, and here like usual it's like it will be coming like 56. So at the end it will be coming like 30 by 56. Okay, now next thing is p of x equal to 2, that means 6c3 into 2c2 by 8c5. So this will be coming like 6 into 5, 6 by 6 factorial by 6 minus 3 factorial into 3 factorial, that means 6 into 5 into 4 by 3 into 2 into 2 c2 means 2 factorial by 2 minus 2 factorial into 2 factorial, 1 only will be coming, and 8c5 will be 56 again. So this will be coming like 20 by 56. Okay, so you got p of x equal to 0, x equal to 1, and x equal to 2. Okay, so these random variables I'll write 0. Okay, just I'll change the color, Okay, so here we have got the probabilities like P of x like 0, 1, 2, and P of x as first one was 6 by 56, next one was 30 by 56, and the third one was 20 by 56. Okay, now we are asked to find expectation of x. That means that summation of x into P of x. Okay, that means summation like 0 into 6 by 56 plus 1 into 30 by 56 plus 2 into 20 by 56. Okay, so the answer will be equal to 1.25. Are you getting the answer? And if anyone has any doubt, please inform. So the answer will be coming like 70 by 56, I think it will be coming. So 30 plus 40, yeah, 70 by 56, answer will be 1.25. So if you are clear with the answer, you can just tell me, otherwise I can explain again. Not visible, last line. Okay, yeah, okay, what I'll do is like, yeah, just okay, so earlier what I have done is I have given this P of x equal to 0. We had got like it was 6 by 56, right? And P of x equal to 1 as 30 by 56, and x equal to 2 as 20 by 56. Okay, these three we had got. Now we have to find out what is the probability for each of the case. Okay, then for that so for that we have written what are the x values. So x values are like 0, 1, 2, 0 defective item, 1 defective item, and 2 defective item. And P of x is given like it is given like 6 by 56, and this one 30 by 56, and 20 by 56. Okay, so expectation of x we are asked to find. So expectation is usually given by summation of x value, the random variable value, into probability of that particular x value. Okay, that means first x value is 0 defective item and its probability is 6 by 56. Then the next one is like the next value, so it's summation, so plus 1 into 30 by 56 plus 2 into 20 by 56. So it will be coming like 30 by 56 plus 40 by 56. So it will be like 30 plus 40 by 56. That means it is 70 by 56, which will be calculated, and you will obtain it as 1.25. So I think this is clear now. Okay, so I'll go on to the next question. A sample of n observations are independently drawn from a random distribution. The sample variance follows. I have already written the answer. It follows a chi-square distribution with n minus 1 degrees of freedom. Okay, you have n observations independently drawn from a normal distribution. Okay, sample variance will follow chi-square distribution. Okay, that's just the theory. Then which one of the following is the best measure for central tendency for categorical data? This also you have seen in the initial lectures of week 3. So it's like if it's categorical data, the best measure will be mode. Okay, so that's also fine. Now next thing is like, so it's the earlier one was categorical data, right? So now the next thing is like, we have x and y values of two independent random variables with variance of x given as 9 and variance of y given as 3. Okay, so we have to find out variance of 4x minus 2y plus 6. So we know a relation like if variance of ax plus by plus c is given and we want to find out that, okay, we are given with variance of x and variance of y. So variance of x given here is right now 9 and variance of y is given like 3. We are asked to find out 4x minus 2y plus 6. So variance of 4x minus 2y plus 6, so that's what is written. So we have to do like a square into variance of x means 4 square into variance of x, and even if it's minus, the variances will be added only. Okay, variances in the data will be added only. That's why we are getting like plus b square. It's given minus 2y, but if you have individual variances, then variances will be added up even if you have a negative value there. Even if the relation given is negative, the variances will be added only. So that's why we have 3 square into variance of y. Okay, and the other one is a constant, we won't be taking that, no variance for that. So that's why we are getting 16 into variance of x is 9 plus 9 into, sorry, it's like, sorry, this one variance of y, so minus 2y, here it will be like 2 square. Okay, so yeah, so it will be like 4 into variance of y is 3. So you'll be getting the answer for this one as 156. That's the answer. I hope there are no doubts in this particular question. Okay, then I'll move on to the next one. So calculate the standard error of the sample mean using the following data: n equal to 14, mu equal to 18.5, x bar equal to 17.85 and s equal to 1.95. Answers are given here. So just it follows a normal like formula only. The standard error is, we are asked to find the standard error, and standard error is given by s, that is the sample mean, and the n value by root n. Okay, s by root n we have to find for the standard error. So s value is given like 1. So this is like the s value, so it's given like the sample standard deviation is s, so 1 by 1.95 by root n, which is 14, that you will be getting the value as 0.52. Okay, then okay, now we have another question, that is like find the t statistics for the sample data given that the population mean of the distribution is 8. Okay, so we can do this with the help of RStudio, as well as we can do it in other way. So you are given with the sample. Okay, so for conducting a t-test, this is usually done when the variance is not known. Okay, so it's used for sample size less than 30, and based on the student t distribution, it will be given like this one, z equal to this one. So t value, since okay, what we have to do for a t-test. So earlier we had done an z-test on the data. Now we have to do a t-test on the data in RStudio. So the code is also given there. Now this is the question: t-statistic for the sample data given the population is represented by population mean is given by 8. Okay, that is the only thing which is given, and the data also is given. So for that I have samples equal to 5575454 and I have to do a t dot test equal to samples which is given by the data and mu equal to 8. Okay, so if I do that, the t test will be coming like this one. Okay, so one sample t test, data taken from samples which was given like this, t value is coming like 0.83 minus 8.33 and degrees of freedom is 9. Okay, because there are 10 data and n minus 1, like that it's coming, and p value is coming like a very small value. Okay, that means that the null hypothesis is accepted, accept H0. Okay, that will be coming. Okay, so I have written the full snapshot of the program also here. The mean of x value will be coming like 5.1 and the t score will be coming this one with a p value of this one. Okay, now the 95% confidence interval is given like 4.312 and 5.8872 for this particular data. Okay, now the same thing I will do for another data. So this is a different kind of data with the same mu and samples given. For this particular data, t value is coming like this and the p value also is coming, but it's still less than 0.05. Okay, so you'll be accepting the null hypothesis. In this case, the alternative hypothesis is given by true mean is not equal to 8. Okay, that is the null hypothesis given. Now, sorry, that is the alternate hypothesis given. So null hypothesis will be like true mean equal to 8. Okay, which is the significant value given by the p value, which is significant given by p value. Okay, so that is the t statistic. Now you have find the f statistic for the following sample sets generated from the same distribution. So in the case of, usually for t statistic you will be having, if you have to find it out in a data which is given, then it will be like the t value, t score will be given by, usually you will be having the, so it is like a difference of means will be taken in that case, and you will be taking it like x1 bar minus x2 bar usually. Okay, it's in the case where it's a test for difference in means usually. Okay, so x1 bar minus x2 bar by root of s square by n1 by s square by n2, like that will be coming, root of s square by n1 plus s square by n2, that is the usual case. Okay, yeah. Then f test. So f statistic, so at the end I have given, so the difference in variance, if you want to find, you will be looking for the that kind of a statistic. Okay, so here you have two sets of data. Sample data 1 is given like 8.6566774 and the next one is 15, 15, 11, 9, 13, 5 and 12. Okay, so it's like first you have to give sample 1 equal to C this one, sample 2 C this one, then var dot test. Okay, sample 1, sample 2, you are not given with any other data, there are no variances given, there are no standard deviations, or even the mean also is not given. Anyway, population, the sample mean you can calculate and everything you can calculate. Okay, the standard deviation, everything you can calculate, but if you do it in the RStudio, just you have to load the data So these are the data which is given in the question. Sample 1 equal to C of list, we will form a list with 86567774, and sample 2 is given by this one. I'll just enter the data, and then we are giving like var dot test for finding the F statistic. Okay, sample 1 and sample 2. So for that, in F test you will be getting like the F statistic value, then the degrees of freedom. Here it is given like numerator degrees of freedom and denominator degrees of freedom. So since it's like a the null hypothesis here will be like sigma 1 square by sigma 2 square, or we'll be finding like the population variances are equal. Here in this case, in F statistics, you will be finding like the null hypothesis will be like population variances, the variances are same, are equal, like that will be the hypothesis. Okay, so for that it will be like, or it will be written like sigma 1 square by sigma 2 square equal to 1, that will be the null hypothesis, and the alternate hypothesis will be coming like sigma 1 square by sigma 2 square is not equal to 1. That is usually used in F test, okay, to compare two variances. So in this one, the degrees of freedom of first one is 6, and for denominator also it is 6. P value is coming like 0.0324, which is less than 0.05, meaning like the null hypothesis H naught is significant, okay, because it is less than 0.05. Then the alternate hypothesis is written by true ratio of the variances is not equal to 1. That is the alternate hypothesis. That means the null hypothesis is the true ratio of variances is equal to 1, and since it is less than 0.05, it is accepted. Okay, the null hypothesis is accepted. Now what you can see is like 95% confidence interval. In this interval these values are coming, and the ratio of the variances is this much. Okay, so 0.1433, that is the value that we'll be getting. Now the next question, so any doubts you can ask, otherwise I'll be moving on to the next question. Okay, so if find the F statistic for the following sample sets generated from the distributions with population variances 3 and 7 respectively. So variances, population variances are given here like sigma 1 is like 3 and sigma 2 is like 7. Okay, and sample data are also given like this, 16 like this, You have to find the F statistics. So since the population variances have been given, we will be using a different method to solve this one. So what will we do? Actually the F score is like the ratio of the variances, like for example population variances, you'll be finding the you will have to find out the variances, ratio of the variances, right, from the samples. So right now you are given with population variances sigma 1 and sigma 2. Okay, sigma 1 square and sigma 2 square. Sigma 1 square is given like 3 and sigma 2 square is given like 7, because sigma 1 denotes the standard deviation. Okay, so that's why. So sample X I'll be loading like, so we'll move on to the RStudio for this one. So sample X is like C of 16, 12, 34, 27, 32, 27 and 31, and sample Y equal to C of 25, 24, 14, 25, 32, 27 and 32. So these two values I will be loading here, and then since it's straight away given, okay, we have to see the variance, sample X and sample Y. How you find out is like you have sample X you will be taking, okay, sample X, and you will be finding the variance for sample X. So if you run this particular thing, you will be getting like variance as 70. So 70 divided by 3 will give you that ratio of the sample as well as the population, and variance of sample of y divided by 7 will give you that particular value. So if you run these two, you will be getting that division. Now when you round up, when you get variance of sample x divided by variance of sample 2, then you will get the F statistic value, and you can round that to the nearest 2 decimal places. Okay, if like that you do, you will be getting like 4.36. so the value will be coming like 4.36. okay, so that is the F statistic value. Now what next question is like, when will you reject the null hypothesis? Okay, so that you know, when p value is less than alpha. Okay, so sorry, null hypothesis will be rejected when p value will be greater than a. Okay, we'll compare our p value with alpha, and p value, okay, there is a small problem here. Okay, so it's like p value is less than alpha, we will accept the null hypothesis. Okay, less than or equal to alpha, okay, let me see. Anyway, yeah, so the answer was given like this. Okay, now a standard normal density function is shown. The area of the shaded region is, okay, so for this one we have to find the area of the shaded region. So there is one method to do that. So for that I'll just be like taking this particular thing. Okay, so you have to go to this site, and like for example, it's like just wait a moment. So there is something here like this is one site. Okay, I have given the site in the presentation also. So in this site you can see, like, if you have it like this, okay, you can vary the value and see the set value as well as for the particular confidence interval. Okay, so this is the standard deviation and the set value. Okay, now so likewise, standard normal density curve is given. It's between sigma value, okay, and this is given like between -2 and +2. Okay, so just if you go to this one here, you can find that it is like 47 point. So it's like 0 to z and up to z and z onwards, like that it's given. Okay, so 0 to z, if it's like this, so we are asked to find till 2, right, from -2 to 2. So it should be like double of this one, double value of this one. So 47.61 plus 47.61, the value will be closer to this particular value. Okay, 95.954, that is the value. That means 95% confidence interval is between sigma value is equal to -2 and +2. That is the value. So that is the answer. Now a talent exam is conducted annually which has a mean score of 200. I have written that here, and a standard deviation of 30. Just a moment. Standard deviation of 30. If a student's set score is 1.5, then what is his score in the exam? So mean value is given, standard deviation is 30, set value is 1.5. okay, so x is equal to mean plus set into standard deviation. Okay, so this you know, right? So since it's given like this is like z equal to x minus mu by sigma, that's already given. So you are asked to find out the x value, which is mu plus sigma into z value. Okay, then you will be getting the value as 245. It's straight away the answer. Okay, now we'll move on to the next one. Just wait for a moment. Okay, yeah, a car company purchases engine blocks from suppliers A, B and C. Out of the 100 units supplied by A, 2 units were found to be defective. So 100 units were there, defective is 2. Similarly, out of 200 and 300 units supplied by B and C, the number of units found to be defective were 10 and 15. Okay, so you have A, B and C, and the number of things supplied by them is 100, 200 and 300. Now in that, defective was found to be 2, 10 and 15. If a quality control person picks up a block and if the selected block is from A, what is the probability that it is defective? So actually you don't have to do any serious calculations here, because right away you can do that, because you know that the total number of things from A are 100 and the number of defective from that is 2. Okay, so picks up a block and if the selected block, you can directly do that. Okay, don't have to do everything and select that. So the answer will be coming like 0.02. Okay, so here I think we have come to the end of this week's questions. So just this one I have just given. Okay, like I have just given in the RStudio and have given mean equal to 200, standard deviation like that. So you'll be getting the answer as 245, and the next one also have given in the RStudio. Okay, so these are the end of the things. Okay, so just I will check whether anything is missing from the things. Okay, or yeah, so till now what are the questions which are given in the present week. So if you have any doubts, you can ask. What is the test mode for the last exam? Is it's computer based, but you won't be finding questions related to R. Okay, but still you have to wait till the last thing. Okay, last week and get the information from them itself, because if there is any change in the mode of the examination, that you have to see. So I think similar questions are there only for the other things also. Yeah. Negative marking, that will be there, right? I think so. This one about that unproctored, I am not sure. You can ask in the discussion forum, okay? I'm not sure about that. I think there is negative marking. Anyway, yeah, I'll write these things and next week I'll tell that, okay? I'll just clarify that and next week I'll tell whether I think there is negative marking in the exam and unproctored, that I'll see. This also Vaishali, I'll tell you next time, okay? Okay. Any other questions? Are the present week questions similar to this one? I think the submission date will be till do you have the submission date for that? It's 14th, right? Submission date is 14th, yeah. Okay, so you can solve the things. It's similar to, I think, most of the weeks in the previous courses I have seen similar questions only. So I think this is comparatively an easy week this time. So, and the questions are repeating. Recording is available in that problem solving session, okay? In the problem solving session tab in your present course.